Solar flares are one of the most powerful and fascinating phenomena occurring on our Sun, yet they remain a mystery to many. These sudden, intense bursts of radiation are not only a spectacle to observe but also have significant impacts on space weather and communication systems on Earth. But what exactly is a solar flare, and why should we care? A solar flare is a sudden and intense burst of radiation emanating from the Sun's surface, specifically from regions where the Sun's magnetic fields are extremely strong. These flares are the result of the Sun's magnetic energy being suddenly released, creating an explosion of energy that can be seen across the entire electromagnetic spectrum from radio waves to gamma rays. The Sun's surface is a seething cauldron of plasma, with magnetic fields that twist and turn due to the Sun's rotation. Sometimes, these magnetic field lines become twisted and tangled, storing enormous amounts of energy. When the stress on these magnetic fields becomes too great, they can snap and reconnect in a violent process known as magnetic reconnection. This reconnection releases energy in the form of a solar flare. The impact of solar flares. While the energy from a solar flare is too dispersed to cause any harm to humans directly, it can have significant effects on our planet. The radiation from a solar flare can disrupt the ionosphere, the layer of Earth's atmosphere that reflects and modifies radio waves used for communication. This can lead to temporary blackouts in radio communications and disruptions in GPS systems. Additionally, solar flares can produce energetic particles that, when reaching Earth, can affect satellites and even power grids, potentially causing outages. Solar flares and space weather. Solar flares are a key component of space weather, a term that describes the conditions in space that can influence the performance of technology on Earth. When a solar flare occurs, it can be accompanied by a coronal mass ejection (CME), which sends billions of tons of solar material hurtling into space. If this material is directed toward Earth, it can interact with our planet's magnetic field, causing geomagnetic storms that can enhance the auroras but also disrupt satellites and power systems. Understanding solar flares is crucial as our reliance on technology grows. Scientists continue to study these solar outbursts to predict their occurrences better and mitigate their potential impacts. As we learn more about solar flares, we gain insights not just into the workings of our Sun but also into the challenges of safeguarding our technological infrastructure from the forces of nature.